Hello. Let's have a look at how to derivate a quotient. Converting this quotient, as you see here, q of x, which consists of f of x over g of x, obviously provided that g of x is different than 0, we don't want 0 in the denominator. What we can do, first we're going to express this quotient as a product. Then we differentiate the resulting expression using product and chain rules as applies. Then simplify the result, also trying to keep the exponents positive. So differentiating as a simple quotient function, if you have a function q of x which is f of x over g of x, with g of x different than 0, and these two functions f of x and g of x are differentiable functions, then we can express q of x as f of x times g of x at power minus 1. That's how you convert that denominator into a numerator as well. The derivative of this q of x is going to be derivative of f of x times g of x at power minus 1 remains unchanged, plus f of x is unchanged this time, times we derivate this g of x at power minus 1, which is going to be, now that we know how to calculate the power of a function, is going to be minus 1 the power times g of x at power n minus 1. So minus 1 is going to become minus 2 times the derivative of that argument g of x, whatever you have in the square brackets. So it's all that derivative of g of x. This is a method that works, as you can see, for a simple quotient function. We also have a quotient rule. So let's look at that formula, how it looks. So you keep it as a quotient. On the numerator, we're going to have the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, and everything divided by the denominator at power 2. So this is your quotient rule. And with this quotient rule, we actually conclude all these sets of derivatives for polynomial functions. We still have quite a few things to learn about, but based on these rules, you should be able to calculate the derivative of any polynomial function a lot faster than what you would do with the first principle definition of the derivatives. Thanks for watching.